I have these remotes where the edge of the shell has broken off in different places, and every so often the buttons meant to open a gate don't work right away. Let's see what I can do to fix these remotes next. Before working on anything, I want to wash off some of the muck that's built up over the years of use. I'll use a toothbrush and isopropyl alcohol on everything, including the electronics. Something that seemed obvious to check is the clamp that holds the battery in place. This strip of metal here is loose on all my remotes, but because all my remotes are like this, I'm not sure if that's a feature of the clamp or if it's gotten loose over time from usage. I want to test continuity from the loose clamp in two ways. First, I'll press the outer surface of the clamp against one of the probes. With the other probe, I'll check for continuity from random components on the board. I'm not very familiar with board circuitry, so I have no idea what the components I'm testing are for, but they did test successfully on both remotes. For my second test, I'm going to slide the probe into the inner surface of the clamp, so now I'd be pulling it away from the board, causing the loose clamp to move in the other extreme of its loosened movement. Continuity tested fine, so I'm not sure what else I can check for these remotes. I'll move ahead and work on fixing the broken enclosure of the remotes. While preparing to work on a replacement cover for the remote, I noticed something strange with the buttons, and it could explain why they randomly fail to work. As you'll see next, this is more of a mechanical problem, not an electrical one. I first used the Oxid on the buttons to clean and lube them as is described as its intended use on the packaging. I also used IPA since that always seems to help clean off residue from board components I've used it on in the past. My primary goal for the remote rebuild is to have a longer lasting battery setup. The stock 2016 battery has a capacity of 100 mAh. The 2032 battery I'm switching to has a capacity of 3 Ah or 3000 mAh. That's a 30x difference in performance, or about 7 years of use, compared to my current 3 months. I'm checking the voltage of the stock 2016 batteries so I can compare them against the 2032 batteries I want to use. In series, the 2016s are about 5.8 volts, while the 2032s are about 6.6 volts. It's almost a volt difference, but the 2016s have been in use for a while. I wanted to make an entirely new case for the remote, but I think I still need some parts like the rubber cover because the push buttons work well with the tiny buttons on the circuit board. I'll see how things turn out since I still don't have a definite case design that I like yet. I have the circuit board and battery compartments wired up for testing. This is the basic wiring that should work. I have only to combine this wiring with a final construction design. With the 2032 batteries in each battery compartment, I want to measure the voltage at the circuit board to confirm it's getting the correct voltage of approximately 6 volts. For now, I'm going to make a usable case, but not an ideal one. Mostly because I've been using a single remote for months now, and I do need another remote to keep around the home for random use. It's a bit of a pain to have to keep looking for my car keys to empty the trash or let my son in the front gate. It'd be nice to have a spare remote in a convenient location around the home. My idea for a case makes use of the existing case. I'll first have to get rid of the keyring portion of the case before combining it with the battery compartments for construction of the new case. It's easiest to remove the keyring on my belt sander, giving it a nice flat surface once it's removed. These are all the parts ready to be assembled. A circuitry part is not shown, but I'll cover that towards the end of the assembly. I want to start with the top half of the remote. Nothing changed here, so I'm mounting the circuit board back into its rubber button sleeve, and that goes back into the plastic shell. I have to cut a hole in the rubber sleeve for the battery compartment wires to pass through. With that hole cut, I can then cut a hole in the plastic shell that aligns with it. The final step in this stage of the assembly is to glue one of the battery compartments to the outside of the bottom half of the remote. The battery compartment has a similar width to the remote, so it'll blend in with the shape without any additional work. I felt it was easier to glue one of the battery compartments in place first, then use that one to more easily align and glue the second one in place. About 2 hours into the glue's drying time, I decided to remove some of the excess glue that squeezed out during gluing. This is so the second battery compartment will have a level surface to sit on when it's being glued in place. It's been about 10 hours and I decided to glue the second battery compartment. Lining things up should be a lot easier since it will sit edge to edge with the first battery compartment. Not shown in this clip, I did weigh down both battery compartments with a 1-pound weight while waiting for the glue to cure completely. I've made some additional modifications by gluing the wires to the shell and gluing tabs to the end of the wires. I've also glued a piece of cardboard between the polarity tabs so the tabs can be positioned into the old battery compartment and function similar to how a coin cell would have. Putting everything together is easy. I just need to be careful when pressing the two halves together, making sure not to pinch the rubber sleeve between the edges. The rear of the shell doesn't want to snap together, but the two halves are holding in place. I'll tinker with the internals to see if I can get the halves to seat together more securely. Here's the completed remote. I found that the thickness of the cardboard and tabs prevented the case halves from closing securely. Since it's just cardboard between the polarity tabs, I used a plier to crush the glued pieces and that helped the case close a little more. The remote is working like it's supposed to. Opening the lobby gate and parking gate seem a lot more responsive now with the slightly higher voltage 2032 batteries. I also like the on-off switches built into the new battery compartments. For my own peace of mind, I tend to turn the power off when the remote isn't in use. Whether this remote lasts the 7 years I calculated remains to be seen. I have hope since my previously converted car remote, which used to last about 3 months, now has been using the same battery for a year and is still going strong. Leave any questions or comments you have in the comment section down below. That's all I have for now, and I'll catch you in the next video.